Hello everyone, welcome back. So let's continue now and take a look at the whitewater system. And the first thing we need is the whitewater source itself, and then we're going to set up the sim. So let's create a new geo node and call this whitewater source. And all we need is the cache. This cache should include the points as well as the surface fields and the velocity. And to create for the whitewater sim and the sourcing, we only need the surface and the velocity. But remember, we have a lot of points here. If we unpack points, we have 1.5 million points. If we go to a different frame, it's a lot of points. And when you have a sim that has 30 million or 50 million, it's going to be huge to read these points that you don't need them. So the best thing to do is to separate the points from the surface field. And we're going to do that using a blast node. I'm going to say @name equals surface and @name equal val. I'm going to delete non-selected. This is going to look like it's empty, but it's not. We have the surface field and the velocity. And the idea is to write this to disk by itself. Okay, and I've already done this, so I'm going to load it in. I'm going to change this to my local cache. And if we look here, we have the surface field, and let's put down a ROP just to make sure that it's clear. So I'm going to write this to disk. Okay, I'm going to set this to frame range and hit save to disk, and this is the read. Now if we play through, you see it's much faster because we're only reading the data that we need. Okay, and this is very important because later on, if we're playing, if we're reading 50 million points, it's going to slow down everything, not just the whitewater sim. It's going to slow down any other processes related to this. Cool. So the next thing we need is the whitewater source, which needs only this part. Okay. So if we just use the default settings, you can see we're getting is analyzing the surface, the SDF, and the velocity field, and it's giving us a volume field. And this is what's going to be used to scatter the points. Now, with a splash like this, we only care about a specific area. Okay, we don't have a lot of curvature in this. It's very uniform, so we don't need the emission from the curvature. The acceleration, if you guys remember, the splash goes up and then it goes down. When it goes down, we don't need to emit foam. Okay, and when it's going down, the acceleration is still high because the velocity is high, so we don't need to emit from acceleration. We only care about the vorticity emission. We only care to emit where it's turbulent. Okay, and let's lower this to 0.14. And if we play through, you can see it's gonna emit, and that's the sim going up. And then if we play through forwards, it's not gonna have anything falling down. It's not going to have the source coming in. You can explore using different emission, all these sources, but for the final result that we used, it didn't include any of this. And let me pause and show a quick test. So this is a test using various different sources. This is a custom method to populate the points, and this is using acceleration and vorticity, and this is using the vorticity mid-range. I think there's two different values, but as you can see from the various result here, it's still emitting when it's falling down. If we go through, you see here is those streaks coming in, and we don't want that. And pretty much the best version of all of these is this one. You can see also here it's still emitting. You get these streaks coming in, and this method is the best for this type of effect. Now we highly encourage you guys to explore emitting. As you can see, Igor did a test trying different sourcing techniques, and it really depends on the sim and how it's moving. In this case, we found that the vorticity is the most useful, and it's going to help create the most realistic splash effect. Now I've cached this to disk as well, and I'm going to load it in. It may look a bit different because of the I may have not used the exact same settings, but it's very, very close. Okay, yeah, it's very, very close. Maybe we should get the same. Okay, so we can explore this area here, and if we set this to -2, maybe let's go back. Let's set this to -0.5. Yeah, you can see here it captured another interior, and that's basically going inside. So the 0, if we do this, if we do VDB convert and convert it into a polygon, and I need the surface field. Okay, so if I convert this, you can see this surface here is the 0 level. Okay, that's 0. Anything inside is negative, and -5 is going all the way inside the volume. Okay, so -1 is going to be very shallow, just on the surface, and -5 is going to capture everything all the way inside. And if we wanted to capture things above the surface, which we don't want, but you can see it's doing this now. It's capturing the outer shell of the geometry, and we don't want that. So let's set this to -2, and it's very close to this, to the original settings that was used. And let's set this to 10. Okay, so that's pretty much it for the source, and this is what we're going to use to emit the white water. Thank you guys for watching, and see you in a bit. Bye bye.